Hello, everyone. Some technical difficulties, but we're getting somewhere. So welcome to our session about NeuVector integration with AWS CodePipeline. My name is Dominik Wormbacher. I'm partner solution architect at AWS for SUSE. So I help SUSE customers to bring workloads to AWS or improve workloads and improve integrations. And with me is Kevin Iris.
And I'm Kevin Ayers, and I'm a solutions architect with SUSE. Focusing on emerging technologies, containers, AI, that kind of thing, and part of the Amazon Partner Alliance.
Perfect. So, what you can expect from that session today. We take a brief look on NeuVector as a product, the features, high level, just to ensure that we're all on the same page. Then we talk a bit about the actual type of risks that we want to mitigate as part of our code pipeline, as our CI/CD workflow. Then a bit more about the architecture of that, how different pieces fit together. Then a walkthrough where we really see, okay, I trigger this, then this happens, so that you get an understanding how it actually works. Then some resources where you can learn more about that solution and dive even deeper on it. And then we take a look on NeuVector on the AWS Marketplace. And now it's up to Kevin.
Okay.
Do you want that one?
Sure.
Or do you?
Yeah. So what is NeuVector? NeuVector is a holistic supply chain and Kubernetes runtime solution. All right. Thanks. And it uses virtual network traffic as a source of truth, which makes it pretty unique in its space. So let's think about a little more about emerging security challenges for a minute. And as as applications move to a microservice format, we have new challenges that we didn't really consider in the past quite as much. We need more visibility and control than ever before. And in fact, classic host scanning, network monitoring, and firewall tools start to have limited or no value as we talk about Kubernetes. And as more and more developers are moving to continuous integration workflows, this introduces new attack surfaces, and remediating all of that needs to be automated to keep up with scale. And some water. And so what we need really is a layered or security in-depth approach now more than ever. And if we look at that from a high level, NeuVector answers these challenges, and it solves for both supply chain and runtime policy, monitoring, and security. And so, of course, with NeuVector, we have fast, lightweight CVE scanning for the pipeline and runtime. But we also scan the component packages within the images, both in the network and runtime space, by applying threat-based and zero-trust controls in the form of policy as code, which is important, especially if we're to do this at scale. And by zero trust, of course, we're talking about defining anything outside of a normal application behavior as being flagged or blocked according to whatever policies are pre-configured, right? So let's dive a little deeper into the risks we're talking about today. I want to talk about the development process. Over the right slide? Yeah. There's a fairly standard CI/CD pipeline that everyone's familiar with. Developers change code, build, test it, deploy it, and then we expect a certain thing out of the application, right? There's a crucial part missing from this image, which is that typically people start thinking about security at runtime, right? So everything's deployed. Now we have security concerns. And we often focus on integration tests and the CI/CD workflows before pushing to production, but security vulnerabilities or unwanted behavior, undetected supply chain attacks, that kind of thing are left out. And so we need to begin to mitigate those risks as part of the pipeline before the apps are even pushed out to test. And we do scan for CVEs and runtime, of course, but we also do this at various points within the pipeline. And NeuVector scans every layer of the container image and component packages, and then alerts on vulnerability levels with or without a fix, And Dominic's going to illustrate that in a couple minutes here. So, to expand a little on that, admins, usually assume that our development tools, the cloud, or even Kubernetes itself is going to provide the minimum necessary protections for our data and for our customers. And really just the opposite is true. We end up being left blind into the Kubernetes network. And NeuVector really brings unmatched visibility, monitoring, and control of all the network traffic and container processes. We tap the network at the virtual switch and can even do packet capture on east-west traffic within the cluster. NeuVector recognizes layer 7 protocols and automatically scans for known network threats. It scans and reports on CIS benchmarks and provides web application firewall and data loss prevention between containers due to its deep packet inspection. And we're looking for things like anomalous process spawns, unexpected traffic, compliance violations, unexpected file access. All of these things are going to be stored as part of a profile and exportable in the form of policy as code. Let's look at the architecture very quickly. So this is NeuVector installed on EKS. And typically a 3 availability zone deployment. All of the downstream clusters can be either federated directly back to the master cluster, parent NeuVector cluster, or become part of the policy as code within the CI pipeline. So we can install and federate to EKS Anywhere, whether it's on Outposts, using Amazon Linux or BottleRocket, EKS distro on-premise, Rosa, Tanzu, any CNCF certified distro. And NeuVector provides a number of ways to integrate with the pipeline and Amazon services, including REST API, CLI, syslog, RBAC, OIDC, SAML, LDAP, webhooks, etc. Dom, you want to talk about the big picture?
Thank you. I would like to jump back on the architecture real quickly. So thanks, Kevin.
Sounds good.
Yeah, I think it's just what I want to outline and highlight here is when we talk about this. Oh yeah, that's a standard architecture, but what makes these architecture actually best practice and high available? I think that's something we should briefly talk about. I mean, you have the managed control plane from EKS, which is managed by AWS, so you consume it for your standard tools like kubectl, Helm, and all these things, and it's high available. So we take care about spinning up additional nodes, right-sizing the nodes for your workload on the control plane, and then in the middle you see the VPC on the customer managed side, so that's in your account. This is where your worker nodes are, and then you have this choice that Kevin was talking about, like, okay, I want to run maybe nodes managed by EKS, so where EKS takes care about the operating system and all that stuff, or I want to deploy RKE on EC2 instances. But when I then also bring Rancher into the picture, I can update it, so all these tools tightly couple into each other. And then in this talk, we go from NeuVector to that actual deployment and building layer. And that's what we want to talk about. So, big picture. Nice, right? Shiny things. So, this is just an assumption how an application deployment on AWS might look like in your environment. You have an EKS cluster. You consume your container, your application from ECR, from our container registry. Then you have different build tools. Use code build, code commit. We talk about that in a second. You consume identity and access management. You consume roles, policies. Your customers consuming your application through CloudFront, Elastic Load Balancer. So these are all the components that might be there, you're familiar with. And today we want to zoom in left and bottom into all these different development and code tools. So how can we actually go from our code into production so that customers can access my application through, for example, CloudFront? And this is how such a workflow could look like. I want to spend a bit time here. I want to walk you through that, and we start left at the top with the developer. So your developer does something. Everything is modular. So yes, in my reference architecture, I use Cloud9 as a web IDE to develop things, but you can also use PyCharm, Visual Studio Code, whatever your developers prefer. So that's, you can just replace building blocks from that. So we start with our IDE, we write some code, we commit that code in a Git repository. That's step number 2. And then we reach code commit. Code commit is the AWS Git repository. Again, modular, so you could also replace it by GitHub. If that's more of your workflow, push your code to GitHub. Then we have step number 3. We go from the code in a Git repository to CodePipeline. So I commit code, I commit my code, I push my code, and that triggers an event. CodePipeline receives that event and will initiate different stages of a pipeline to actually deploy my application. This is where we hit step number 4, and then we zoom in into these different stages that my deployment goes through. So the first step is source on the left side. I get my source from code commit. I check that out so that code build can use it. Again, modular, that code could come from GitHub, S3, whatever. Then we have step 5. We move into the build stage of our pipeline. We use code build as our service. So this is kind of where our actions are running, where we do something with our code. The build stage contains about things like, I get credentials through an IAM role from AWS to actually log into ECR, because I need that later to actually push my image. I install packages, pre-requirements that I might need to build my container, to test my application, or whatever I want to do. In that build stage, we start with building the Docker container based on our source code. Then we start a NeuVector standalone scan on that local image. We will receive a result from NeuVector. Result in form of, I found this amount of vulnerabilities, high severity, medium severity, low severity. Then we decide what to do. So if we want to fail our pipeline, then we want to circle back so that the developer has to fix issues that were found and start over. Or we say, yep, we are happy with the results, so there were no critical vulnerabilities found. We want to move on. That's the point where we then push an image to ECR. And as you see, we do all the scanning inside our build phase. So we're not first pushing an image somewhere and then scanning. We first scan before we then decide to push. I think that's important because that way we ensure that an artifact never reaches a central registry before we are sure that we are happy with the result, with the outcome. Sorry. So let's assume everything is fine, the container was scanned, good results. We move on to step 6, testing. In the testing stage, we again use code build to orchestrate our actions, to deploy our application on our EKS cluster in a testing environment. Could be a testing namespace, could be a testing cluster, whatever your strategy looks like. At that point, we come back to what Kevin said earlier about runtime security. So, with NeuVector, I define a policy, a baseline for my application, where I say, for example, it's a web server. So I know that it's fine that the web server process starts. That container listens port 8080 for incoming traffic. That's fine. I want my website to be delivered. And I know it will access /app. Everything under /app in my container, these files get accessed. That's fine, expected behavior, I want that. Anything else get blocked. Now comes the important part. Let's assume you have a library, third-party library, you use that in your code, everything is fine, right? You update that library, and for whatever reason, a bug in the software, something injected code that doesn't belong there, the behavior change. And now your container tries to establish an outgoing connection to the internet to load a file. This would be blocked at that stage because NeuVector knows you don't want outgoing traffic, which is not related to an incoming request. So at that point, NeuVector will block it, and we are still in our pipeline, we are in our testing phase. At that point, the pipeline will fail because NeuVector says, my container does something that I don't want to. It's against the baseline that I had. At that point, we circle back, we tell the developer, pipeline failed because of that issue, fix it. So it will not arrive in production. If everything is fine, if our container behaves as we want with the baseline, it then moves on, step 7, into production. And now it's important. With step 8, we actually close the loop. We heard that NeuVector continuously scans my cluster. So for everything that runs on my cluster, I'm protected. It takes a look about vulnerabilities, runtime behavior, all these things. And as soon as my code hits production, my regular NeuVector installation kicks in and monitors my application. Why is that important? Let's assume you don't update your application in the next 4 weeks. There's no update. Why should you publish a new one? But maybe the container image you used had any kind of vulnerability which is detected in 2 weeks from now. So in the pipeline, it was fine, you know? At the day where you were scanning it, cool. But in 2 weeks, we say, oops, we found a high critical vulnerability. Then NeuVector will also identify it, but just on a different, in a different way, you know, at a different stage, and also inform you, and then you kick off your development cycle, you update your base container, your libraries, whatsoever, and then everything starts over. And this is how you actually close the loop between development and your production workflow. Theory is nice, but let's take a look how that actually looks like on AWS. So, that's basically more or less in screenshots as a walkthrough what I showed you in the architecture diagram. We start with the developer. In this example, a really basic Docker container. So the first line says we use a base container image from SUSE, from the SUSE registry, to build this container. We say our application lives in folder/app. We copy our code into that folder. We update a bit of npm packages and install an HTTP server, and we start that server, or we define the entry point as starting that server, and we say it's exposed on port 8080. Classic web application, as I explained earlier. We push that code to git commit, to code commit, sorry, and this will trigger an event. Now we're in CodePipeline. I had my code in my IDE, I pushed it to code commit triggered an event with CodePipeline. So we see that, yoo-hoo, event received, code downloaded, and build started. It's in progress. A bit more detail. I want you to take a look on this number. Left at the bottom, the commit hash. So every time you commit something, you push something to Git, you get a unique hash for that commit. And I use that hash across the whole process. I tag my image with that, so I can always refer back to this was the state of my code when it was in my pipeline. This is what I found. This is the status of my image. Just a screenshot to prove it. Commits in code commit, same hash at the bottom, a minute ago, some way. And this is just another view on code build. So right at the top, we see that the initiator of that action is CodePipeline. So you go from code commit to CodePipeline to code build. And then we have 3 phases that we actually customize, where we actually do something. That's at the bottom, where we see install, pre-build, build. Install phase is, for example, I install dependencies, application I need to build my container to test something. The pre-build stage could be used for configuration, preparation of my environment. And then I do the actual build, which is in our case building the container, scanning the container. So, I spare you the other 400 lines of nice console output at that point. I know you want to see it, but not today. So, the important thing, this is after a NeuVector scan finished. We see the image, line 401. At the end, the tag is again our commit hash from Git, so that we always can link it. Line 405 are the vulnerabilities that we found. In this case, 72 with 31 high severity findings, which is bad, right? I mean, we don't want that. And here is another important thing. NeuVector not only scan RPM packages, which are part of your container operating system, but it also takes a look into packages, for example, from NPM, so from your actual application. I mean, you install a lot of libraries, right? So, and it also says, whoops, in that library, we also found some issues. Another thing is, you see this nice scan result submitted. So what we want to achieve is we want full visibility throughout our process. So we want to scan it, but then we want the scan result to go back to NeuVector, to our NeuVector installation, so that we can actually report on that and have a compliance view on that. So, as expected, I mean, we found more than 30 high severity vulnerabilities. We really don't want that image somewhere. We want it fixed. So it fails, return code 1, the build state is failing. This is exactly what we want, because bad image. This is why I think it's so important that we push the results back to NeuVector. At that point, this is a view from NeuVector. So I log into NeuVector, I open the risk report. In my filter at the right top, I search for my commit hash, because again, this is my thing to link it, to track my image. And then I can see registry scan report. This is exactly what was uploaded during my code build back to NeuVector. So I have again visibility, what happened, what was found. I can export that, I can report on it. All right, let's fix it. So again, we start in our editor. So we realized, oh yeah, now that you mention it, we used a pretty old Node.js version. We shouldn't do that. Let's update it to the latest version, latest and greatest, all patches included. So we change the line, we commit, we push. Same as before. This push to code commit will trigger an event which is received by CodePipeline. CodePipeline will download the source code. CodePipeline will start code build. Again, a new commit hash here at the bottom, 99.11191. Easy to remember. So we jump into the end of our next NeuVector scan. New image, we build it, we scan it. Now we have one vulnerability found, which is medium. I defined for my workflow that I'm okay with a medium vulnerability. I mean, everyone can define it how they want, how the compliance of the company is. In my case, I say, okay, high is something that I want to avoid. Medium is something where I want my developers to take a look, but I don't want to block it at that point. It's just my personal decision. Everyone can define the policy how they want. Scan results submitted. So again, we push all these informations back to NeuVector. And now the build state succeeded. Hey, we have something. So we continue, because now we want that image that we built, that we scanned, actually pushed to our container registry. to actually use it for something, right? And that's the step here. And voila, with the latest tag and with our commit hash, we have our built, our scanned, our tested image in our registry. And now from here we go into our deployment process and do all the other things. So, again, view on NeuVector risk report. We search for the commit hash, and we see perfect scan results submitted, only one medium vulnerability, we're good. So at that point, you might wonder, how do we actually communicate with NeuVector? I mean, I run something in CodeBuild. That's an AWS service. It's outside my VPC. NeuVector is running on a EKS cluster, so how can we actually interact? I enabled VPC connection in CodeBuild. So CodeBuild has the capability to receive a network interface in my VPC, so it can talk with my resources that I have in my environment. And then we have basically three environment variables that we need. We exposed the NeuVector controller API. In my case, I did that through an internal load balancer. I just say, yep, an internal load balancer in my VPC to reach the NeuVector, bless you, the NeuVector controller. So, and then we define that. Then we need a username, so nv_username. That's how I authenticate. And then here at the bottom, bless you, line 12 and 13, we have a link to Secret Manager. So what I want to avoid, because this is my configuration file, my build spec, this is where I define what CodeBuild does. I don't want a plain text password in here, you know? Yeah, it's probably a bad idea, right? When we talk about security, it felt weird to put in a plain text password there. So yeah, we have it actually in AWS Secrets Manager, where it's encrypted. And here I tell CodeBuild that the password is called NeuVector admin password. Please retrieve it and inject it as nv_password in my build environment. That way, I don't need hard-coded credentials. I think I talked for 10 minutes straight, so you can't hear my voice anymore, probably. And this is where I hand over back to Kevin at that point, to talk more about where you can learn more about all these cool things and that solution.
Yep. And I have to read from my speaker notes. We finished this presentation moments before the session started. My fault. So, so we have covered a lot in a short time. Thank you, Dominic. You can go ahead and register for a deeper dive by joining us at a hands-on workshop. These are the codes. There's 2 sessions in July. And if you can't scan those from where you're sitting, grab them from us afterward.
Yeah, just stop here real quick. Come on, you want to make them excited.
Oh, yeah. Yeah.
Stop.
Yeah.
So,
well, you're going to get a chance to do it.
So the idea behind these workshops, as you can imagine, I mean, I was rushing through the whole solution at that point. And I have to. I mean, we just have a limited amount of time. So I could just give you an idea how to configure it, but I really want you to understand it, to adapt it, to pick the modules that you need, and to be successful to implement that in your own environment. This is why we have these workshops. There will be 3 hours, maybe 4. We're still working on them, by the way. So, left side, North America, time friendly, 7:30 a.m. Pacific, 10:30 a.m. Eastern time. On the right side, it's for EMEA. You can sign up for free. It will be hands-on workshops. So we will not do a lot of presentation. We share code with you. You get AWS accounts, and then we really dive deep into the whole thing. So the goal is that afterwards, you have everything you need to implement all that by yourself.
Oh, so let's talk about the NeuVector on AWS Marketplace solution. Okay, so this is new. It was published this year, and it's a marketplace listing that uses a Helm install to install NeuVector and a marketplace billing adapter container directly into EKS, a 3 availability zone HA deployment. Everything is sourced from a secure supply chain trusted registry at SUSE, which is SALSA compliant. And that's because you want to have a high integrity tool before using it to secure your environment, right? It's actually, the format is pay-as-you-go consumptions based billing. So, there's great value for the money. You're not going to subscribe to something you only use part of. You're going to pay as you go, so to speak. And there's no auditing, there's no compliance risk. The listing is billed through your organization's root billing account based on geography rather than deployment geography, right? So you can, if your billing account, if your AWS organizational billing account is in the EU, that's what you're billed through. You can deploy across the world. You can federate everything together. The other kind of key point is that every downstream node, whether it's in the cloud, on-prem, out at the edge, wherever it is going to count against your enterprise commit spend. So what we call EDP drawdown. So every single node that's deployed or that's managed by NeuVector counts against that drawdown. The other fun thing is that, so we've got 2 listings for.
But why is that?
Geographic tax reasons, right?
Yeah.
So if you're.
So that's an important part.
Yeah. So choose the correct. Yep.
Yes, that's why Kevin is explaining it to you now.
Choose the correct listing based on your billing account, and then deploy wherever you want. I believe it's in July, with the next release of NeuVector, we will have a 30-day trial built into the marketplace listing.
Yeah, so I think that comes back to the billing adapter that Kevin mentioned, where every month the actual usage get reported. So my understanding is that this free trial will basically say, the first month you run it, we kind of ignore it, and then from the next month onward, you actually get billed, right?
After that, it'll go into your standard Amazon billing.
Exactly.
And the calculation is based on the mean number of nodes running at a time over the course of the month. Right?
Which basically means
it's very accurate.
Right, so you can scale up, you can scale down, you can start small, you can get big, everything is possible. And to your thing, Neil, as Kevin said, so it has geographical tax reasons why we need these 2 listings, why you have a difference between EMEA and the rest of the world. This QR code will lead you to an overview where you have both, so you can just select the right one. As Kevin highlighted, it's not important where you deploy regions or something. It's really about the billing address, the billing country in your centralized billing account. That's important.
Yes. And you'll see these 2 listings.
Ta-da!
Okay, so thanks for your patience.